Swayam Prabha. Digital India. Educated India.
Welcome again, learners. This video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honors in Geography. This video is for the paper of Climatology and is second in the series for the first module on atmosphere. The topic for this current video is Structure and Layers of the Atmosphere. The video is being recorded by Dr. Pallavi Upreti. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM PG, Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayamprabha Channels of MHRD, New Delhi, India. Hello learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Study Center, Doon University, Dehradun. In our previous lecture, we have already discussed the origin, evolution and significance of atmosphere. In this particular video lecture, we will be studying in detail the layers of the atmosphere and their significance and role in supporting the life on Earth. So let's begin. Starting with the objectives. The main objectives which we will be covering in this particular video is to talk about the structure of atmosphere in general, discuss the various layers of atmosphere and their significant characteristics like the troposphere, the stratosphere, along with ozonosphere, mesosphere, thermosphere, along with ionosphere and exosphere layers. And finally, we will be discussing the importance and relevance of each atmospheric layer one by one. So all these things which we are going to discuss here will fall under the part of structure and layers of the atmosphere. So starting with the structure of atmosphere, as we have already discussed in the earlier slides, the structure of atmosphere is very unique to our Earth system, and it is a thick envelope of gases which surrounds the Earth from all sides, and it is attached to Earth because of its gravitational pull. The structure also becomes significant in terms of that the structure of the atmosphere is so unique that it acts as a single unified gas. Although it is made up of several individual components, the structure of atmosphere acts as a single unified gas up to a certain height, that is nearly about 80 kilometers above the surface of Earth. The present atmospheric structure can also be studied in terms of its present composition. The present atmosphere is primarily sourced, we have already discussed this, from the Earth's interior, and the composition is predominated with the nitrogen and oxygen gas, making up to 99% of dry air in atmosphere. So the atmospheric structure becomes unique. The atmospheric structure is primarily studied in terms of its composition, in terms of its height from the ground towards the outer space. The structure of the atmosphere is also studied in terms of its temperature and pressure differences, which create different layers in the atmosphere, which we will be discussing. While discussing the structure of atmosphere, it becomes imperative to discuss the height of the atmosphere, because the height of atmosphere, the extent of atmosphere is significant component of the structure of atmosphere. So the effective height for the atmosphere is considered to be 16 to 29,000 kilometers, although there is no specific boundary where the atmosphere ends and the outer space begins, but the scientists, based on several characteristics, have defined 16 to 29,000 kilometers as an effective height of atmosphere. Within this 16 to 29,000 kilometers also, the 10,000, the lower
10,000 kilometers from the sea level is considered significant for life forms on Earth. Within this 10,000 kilometers, also the height up to 1,000 kilometers is considered very, very important for supporting life on Earth. And after this 10,000 kilometers, the 10,000 kilometers is generally called as exosphere or outer atmosphere. After this 10,000 kilometers, the atmosphere, our atmosphere gradually merges with the outer space. So, in terms of height, the height of atmosphere, although is 16 to 29,000 kilometers, but as you can see that the lowermost atmosphere layers or lowermost atmosphere is considered very, very important for life on Earth. Now, talking about the total mass of the Earth's atmosphere, you can see that nearly 50% of the atmosphere lies below the altitude of 5.6 kilometers. So, maximum atmosphere, majority of atmosphere is compacted towards the lower layers of atmosphere, towards the surface of Earth. And nearly 97% of the atmosphere is confined to the height of 29 kilometers. So, as you go up in the atmosphere to 29 kilometers, you will see that 97% of the atmosphere lies below this 29 kilometers, and we have only 3%. Majority of the height of the atmosphere is just 3%, and within that 29 kilometers, the maximum mass of atmosphere is concentrated within those 30 kilometers only from the surface of Earth. So while we study the structure of atmosphere, the effective height is also of great significance. The mass, to understand where the maximum mass of atmosphere lies and how it impacts the life form on Earth, is also significant. Now coming to the other slide.
So the structure of atmosphere is not only studied in terms of individual gases or components or primarily on the basis of its composition, but while talking about the structure of atmosphere, we also take factors like pressure and temperature along with its composition to define the atmosphere, to define the structure of atmosphere, and all these factors together, they stratify the atmosphere into different layers. So based on, after studying the various components like pressure, temperature, composition, it was finalized that the atmosphere does not have same homogeneous character from the surface of Earth to 10,000 kilometers. It differs in its composition, it differs in pressure conditions, it differs in temperature conditions. So based on all these factors, the structure is primarily studied in terms of combination of various layers, which are spherical shells which stratify vertically the atmosphere starting from the ground level. So based on all these characteristics, the atmosphere, although it acts as a homogeneous gas to a certain heights, but based on these factors, they were stratified. The whole atmosphere was stratified into various spherical shells which surrounds the Earth, having definite pressure conditions, definite temperature conditions, and composition. So we will be discussing each layer one by one in all the slides. Now coming to the layers of atmosphere. The Earth's atmosphere consists of few zones or layers like spherical shells which surrounds the Earth from all sides. These layers are demarcated on the basis of various characteristics like temperature and air pressure. However, temperature is one of the significant factors on the basis of which the atmosphere is divided into four major layers. These layers are: number one, the troposphere, which is the lowermost layer of the atmosphere, followed by the stratosphere, which is the second important layer of the atmosphere. Third, mesosphere, which is above stratosphere. Fourth is thermosphere, which is the layer above mesosphere, and it is the outermost layer of the atmosphere also. So we will be discussing each layer individually now, starting with troposphere. Troposphere. So the lowermost layer of the atmosphere is troposphere. It is the layer of atmosphere which is found closest to the surface of Earth, because of which this layer is greatly influenced by the existing surface conditions on Earth and in turn also influence the surface conditions on Earth. The word troposphere itself means the zone or region of mixing. Because of this mixing, continuous mixing, it is a very dynamic layer. Hence, it is significant for biospheric ecosystem, including man. So, because of this mixing, various weather patterns, phenomena, conditions like rainfall, thunderstorms, precipitation in various forms exist in this particular layer, making it very dynamic and significant for Earth. This particular layer, because of its various weather phenomena and various atmospheric conditions, it contains majority of the mass of atmosphere, that is more than 75% of atmospheric mass is compacted in these particular layers, and nearly 50% of the effective atmosphere lies below the height of 5.6 kilometers. So within the effective height of troposphere, till 5.6 kilometers. So within the height of troposphere also, till 5.6 kilometers, 50% of the effective atmosphere is compacted. Further, being closest to the surface of Earth, this particular layer is greatly influenced by the temperature variations and conditions found on the surface of Earth. And there exists a latitudinal and altitudinal variation in the height of troposphere, which is influenced by the surface conditions found on Earth. So, since equatorial regions have warmer temperatures, so air above these regions expands more as compared to the polar regions, and it pushes the upper boundary of troposphere to much more heights as compared to their polar counterparts where the temperature is comparatively lower. So the troposphere, on an average, the height of the troposphere is 16 kilometers above the equator. It is more above the equator, and it is only 6 kilometers above the pole because of this latitudinal influence. The troposphere is primarily heated through terrestrial radiation.
As we all know that our Earth is mainly heated through the solar radiation, and the solar radiation is received in the form of incoming radiations having a shorter wavelength. So while few regions of the atmosphere, few segments of the atmosphere may absorb a portion of these shorter wavelengths, the troposphere, being closest to the surface of Earth, is primarily heated through the outgoing long wave terrestrial radiation emitted by the surface of Earth. So this outgoing terrestrial radiation heats up the troposphere. It increases the temperature of the troposphere. Because troposphere is closest to the surface of Earth, so the lower layers of the troposphere, which are closest to the surface of Earth, absorbs the maximum amount of this terrestrial radiation emitted from the surface of Earth, and therefore they are warmer as compared to the upper layers of the troposphere, which are less warmer. So there is a gradual decrease in the temperature, gradual decrease in temperature with increasing height. So as we go up in the troposphere, there is a gradual decrease of temperature, and this decrease of temperature happens at a rate of 6.5 degrees Celsius per 1000 meters. So this gradual decrease of temperature at 6.5 degree per 1000 meters is called as normal lapse rate. Because of this normal lapse rate, the lower layers of the troposphere are warmer as compared to the upper layers of the troposphere. Here, as you can see that near the ground surface, the temperature is somewhere around 10 to 20 degrees Celsius, and as we go up in the troposphere, the temperature gradually decreases with increasing height following the normal lapse rate, and somewhere around the upper limit of troposphere, it reaches to somewhere minus 60 degrees Celsius on an average. The decrease in the temperature is much more profound over the equatorial areas. Why? Because over the equator, the Troposphere has more extent, vertical extent as compared to the polar areas where the vertical extent of troposphere is just 6 kilometers. Because of this difference in height, there is more decrease in temperature over the equatorial areas, which is from minus 70 degrees Celsius, and over the polar areas, which is somewhere around minus 50 degrees Celsius. So you can say that in the upper limits of troposphere, the polar regions have comparatively higher temperature as compared to the equatorial regions where the temperature is somewhere around minus 70 degrees Celsius. So at this upper limit of troposphere, where the temperature becomes minus 70 over the equatorial areas and minus 50 over the polar areas, it reaches the upper limit, which is called as the tropopause, which is 1.5 kilometer thick layer in the upper limits of troposphere. It is also called as a zone where the mixing stops, forming a boundary between troposphere and the upper layer of the troposphere called the stratosphere.
The stratosphere is the second important layer of the atmosphere above the troposphere. So the stratosphere lying just above the troposphere is second important layer of the atmosphere. It starts from the upper tropospheric boundary or tropopause, which is 16 kilometers above the equatorial regions and 6 kilometers above the polar regions. So it extends from this tropopause to 50 kilometers above the ground level. So this upper limit of stratosphere located at about 50 kilometers from the surface of Earth forms a boundary between mesosphere, that is a layer above stratosphere, and stratosphere. The stratosphere, because it is located above tropopause, which is a zone where mixing of air stops, therefore it is devoid of major weather phenomena and comparatively a stable layer. But there is still a circulation of feeble winds and presence of rare high cirrus clouds in the region called as nacreous clouds. And these clouds sometimes in the polar regions are also called as polar stratospheric clouds. Because of a comparatively stable region, this stratosphere is also used, especially the lowest limit of the stratosphere are also used by the commercial airliners for flying their jets. And this stratosphere is very significant because of the presence of one of the important life sustaining gases, that is because of concentration of ozone. So ozone in stratosphere is found somewhere around 15 to 30 kilometers. So this zone with higher concentration of ozone found in the lower layers of the stratosphere is called as ozonosphere. So when we talk about the importance of stratosphere, this particular section, that is the ozonosphere, becomes of utmost importance. Therefore, it becomes important to discuss how this ozone is formed and how this ozone is important as a stratospheric layer for the life forms on Earth. Therefore, we are going to first briefly discuss what ozone is. Ozone. Ozone is an allotrope of oxygen. It is a triatomic form of oxygen wherein the molecules contain 3 atoms of oxygen instead of 2 normally. It is faintly blue irritating toxic gas with pungent odor, and when compared to oxygen it is comparatively unstable. However, it is 1.5 times denser as compared to oxygen and readily dissolves in water. In our atmosphere, the ozone is found in 2 layers. One is tropospheric ozone and second is the stratospheric ozone. The ozone in the lowermost layers of the atmosphere is just above the surface of Earth because it is primarily sourced due to the chemical compounds which are found on the surface of Earth or emitted because of human activities. The ground level ozone in lower layers of the troposphere is primarily the outcome of chemical reactions between oxides of nitrogen and volatile organic compounds which are primarily sourced from human activities like industrial emissions, vehicular fumes, and air pollution. Therefore, this tropospheric ozone, which is found near the ground surface, is considered toxic, is considered bad ozone, and is harmful and can trigger various health problems. Unlike tropospheric ozone, the stratospheric ozone is considered good. Why? Because it is continuously naturally sourced from our environment. It is a naturally occurring gas that shields our Earth from the harmful solar radiations, specifically the UV radiations, and hence it is significant for protecting biospheric life forms on Earth. Also, by shielding our Earth from the sun's ultraviolet radiation, it maintains the optimum temperature on Earth, which is important for supporting life forms on Earth. Therefore, the stratospheric ozone is very, very important. The stratospheric ozone. How this stratospheric ozone is formed? The stratospheric ozone is primarily an unstable gas, and the creation and destruction is a gradual, continuous natural process in the presence of sunlight. So the oxygen which is present in our atmosphere, specifically stratosphere, breaks apart on being struck by UV rays into highly reactive atoms. So when one oxygen molecule is struck by UV rays, it breaks up into two oxygen atoms, and these highly reactive two oxygen atoms readily recombines with other oxygen atoms to produce triatomic allotrope of oxygen, which is called as ozone. So this is a continuous process wherein the oxygen is continuously broken apart and recombined to form O3, ozone, in the presence of UV rays in the stratosphere. Because of this, the stratosphere has a very high concentration of ozone. But this higher concentration of ozone is also checked from time to time. It is checked and balanced through the same natural processes, and ozone levels are balanced out by its destruction in the presence of UV rays. So on reacting with UV rays, this triatomic allotropes again breaks up into the two atoms forming the oxygen again. So you can see that it is a cyclic process wherein in this particular layer the oxygen continuously breaks up to form ozone, and ozone is checked up through the same process where ozone atoms also break up in the presence of sunlight to reform into oxygen. So this particular cyclic process maintains the concentration of ozone in our stratosphere. The higher concentration of ozone in our stratosphere does very, very important thing for our Earth's atmosphere and particularly to the surface of Earth. That is, it acts as a shield. It acts as a barrier for the harmful UV rays which enters our atmosphere, and it absorbs most of the harmful UV radiation and does not allow them to enter to the surface of the Earth, and it shields our Earth from these harmful UV radiation. Nearly 90 to 95% of the UVC, which has got the shortest wavelength, are absorbed by the ozone layer, and nearly 75 to 80% of UVB is absorbed. Nearly 5 to 10% of UVA is absorbed by the ozone layer. So this ozone layer does not only absorb the harmful UV radiation, but by absorbing a particular segment of the solar radiation, it also maintains the optimum temperature on the surface of Earth. However, over the particular time period, over several years, there has been use of several chemical compounds which completely destroy this ozone in the stratosphere, thereby disrupting the cyclic process of oxygen and ozone, which is very, very harmful to our atmosphere, to our biological life forms on Earth, and it is called as ozone depletion, which we'll be discussing in the other slide. Ozone depletion is a very recent phenomena where there is a gradual thinning of Earth's ozone layer in the upper atmosphere, and particularly the stratospheric ozone, which is a good ozone. It was destroyed because of the chemical compounds. So the primary reason attributed for the destruction and gradual thinning of ozone were the chemical compounds containing gases like chlorine, bromine, primarily coming from the chemical compounds group of CFCs and halogenated gases. So the extensive human activities, industrial activities, they were producing certain ozone depleting compounds which were gradually thinning the ozone layer. As you can see in this simulation, that this ozone thinning was so extensive over the southern hemisphere that it created an entire hole in our ozone layer, and which was considered very much detrimental for our environment. So why this ozone hole is only formed over Antarctica and southern hemisphere? So as we have already discussed that the stratosphere has the polar stratospheric clouds also. So sometimes these polar stratospheric clouds create the condition for drastic ozone destruction, providing a surface for chlorine, which is found in CFCs and ozone depleting substances, to change into ozone destroying forms, leading to extreme destruction of ozone layer, creating a hole over Antarctica. So the polar areas face the maximum brunt of human actions. Since ozone is immensely important, without which ecosystems would collapse with large-scale health problems, and the life as we know of would cease to exist. Therefore, acknowledging this growing threat, the world, the global communities, for the first time came together for a landmarked multilateral environment agreement called Montreal Protocol in 1987, which for the first time recognized that the worldwide emissions of certain substances can significantly deplete and otherwise modify the ozone layer in a manner that is likely to result in adverse effect on human health and environment. And it consequently designated phasing out the production of ozone depleting substances like CFC, halogenated gases, halogens, etc., and several other compounds to protect this life-defining layer of our atmosphere called ozone. So today, more than 30 years post Montreal Protocol, it is seen as one of the most successful global collaborations till today to protect the environment. As a result of which, as suggested by many scientists, that the ozone hole has stopped growing and it has started shrinking, and it is expected to recover by 2070. So these collaborative actions have definitely put ozone on its path to recovery. Unlike troposphere, the temperature in the stratosphere is warmer as compared to troposphere. The higher concentration of ozone in this particular layer can be regarded as one of the important factors for increasing the temperature. So as we have already discussed that nearly about 15 to 30 kilometers from the surface of Earth, in the stratosphere there is a maximum concentration of ozone which absorbs the UV radiation, and because this layer absorbs the UV radiation, the temperature in stratosphere is higher as compared to the troposphere also. So as we saw in the troposphere that the temperature gradually decreased with increasing height, but in stratosphere there is opposite. With increasing height, there is also increasing temperature. Tropopause had an average temperature of minus 60 degrees Celsius, and because of ozone presence, because of absorption of high amount of UV radiation in this layer, the temperature gradually increases, and till the upper limits of stratosphere, which is stratopause, it reaches 0 degree Celsius. So from minus 60, it increases to 0 degree Celsius. So this is the second layer of the atmosphere, and with higher maximum concentration of ozone, this layer, although comparatively stable, has its own importance, own significance for life on Earth. Mesosphere is the third important layer of atmosphere above stratosphere. So the boundary which divides stratosphere with mesosphere is stratopause. It is located at 50 kilometers from the ground level. From these 50 kilometers to 80 kilometers above the surface of Earth, this third layer of atmosphere is found, which is called as mesosphere. The temperature in this particular layer decreases with height throughout the mesosphere and becomes minus 80 in the upper limits of mesosphere, which is called as mesopause. So the lower boundary between stratosphere and mesosphere is called as stratopause, and the upper boundary of mesosphere located at 80 kilometers from the surface of Earth, where the temperature is minus 80 degrees Celsius, is called as mesopause. Very strange high altitude clouds called noctilucent cloud or polar mesospheric clouds are sometimes formed in the mesosphere near the poles. The importance of mesosphere is most meteors which enter the atmosphere, they vaporizes in this mesosphere. Some material from meteors linger in this mesosphere, causing this layer to have a relatively higher concentration of iron and other metal atoms. So this layer, we have seen that there is a gradual decrease in temperature in the troposphere. Then in stratosphere, there is a gradual increase in temperature. Again, in mesosphere, there is a gradual decrease in temperature. So there is an alternative bands of temperature variations which are created in our atmosphere, wherein mesosphere, the temperature is very, very low in its upper limits, reaching to minus 80 degrees Celsius. Coming to the fourth and very last layer of our atmosphere, it is called as thermosphere. The layer of very rare air above the mesosphere is called as thermosphere. So we have already discussed that the boundary between mesosphere and thermosphere, or the upper limit of mesosphere, is called as mesopause, which is at 80 kilometers above the surface of Earth. So this particular layer extends from about 80 to 90 kilometers in the lower limits to between 500 and 1000 kilometers in the upper limits, and gradually merges with the outer space. Although there is no definite limit of thermosphere, but for our convenience, we have kept 1000 as the last boundary for thermosphere. Variations in the amount of energy coming from the sun exerts a powerful influence on both the height of the top of this layer and the temperature within it, because of which the outer extent, the uppermost limit of the thermosphere is difficult to demarcate, and it is kept for convenience between 500 to as high as 1000 kilometers above the ground. High energy X-rays and UV radiations from the sun are absorbed in this thermosphere, raising the temperature to hundreds or at times thousands of degrees. It can reach to 1700 Celsius also in the outer margins of the thermosphere. Although the temperature reaches to 1700 degrees Celsius in the outer margins of the thermosphere, the density of the air becomes extremely low with increasing height, and the air is so thin that it feels freezing if someone would step outside in thermosphere. Often the electrons flying from the sun through this layer collides with the atoms and create very nice glittering effect, lightning effects in the sky in the northern and southern poles, primarily in the northern polar areas, and this effect is called as aurora effect on Earth. So, and it is also called as northern lights. In the northern hemisphere, this effect is called as aurora borealis, and in the southern hemisphere, this effect is called as aurora australis. Thermosphere layer is divided into two layers, that is ionosphere, which extends for about 80 to 640 kilometers. That is, ionosphere is located in the lower margins of the thermosphere towards the mesosphere, and second layer, that is the outermost layer of the thermosphere or the outermost layer even of the atmosphere, is called as exosphere, which extends beyond 640 kilometers. So if you consider the height of thermosphere from 80 kilometers to 1000 kilometers, the initial lower layers of the thermosphere have ionosphere, and towards the exterior margins we have got exosphere, which gradually merges with the outer space. Ionosphere is found in the lower margins of the thermosphere, extending from about 80 kilometers to 640 kilometers. It is an abundant layer of electrons and ionized atoms and molecules. There are several different ionospheric regions which affect the propagation of radio signals and radio communication in different ways. So these ionized atoms and molecules help in deflecting the radio signals, propagation of radio signals, hence important for Earth. So the whole ionospheric region is divided into various small layers, which based on the type of frequency of radio waves they deflect or reflect. So the lowermost layer is called as ionosphere D layer, which reflects low frequency radio waves and disappears with sunset. The layer above it in the atmosphere is called as E layer, which extends from 99 kilometers in the atmosphere to 130 kilometers in the atmosphere. It is also called as Kennelly heaviside layer, and it reflects medium and high frequency radio waves to the atmosphere. The third important layer, ionospheric layer, is F layer, which is also called as epleton layer, which extends from 150 kilometers in the atmosphere to somewhere around 380 kilometers in the atmosphere. And this layer also reflects medium to high frequency radio waves. The final and the uppermost ionospheric layer is ionosphere G layer, which is found at around 400 kilometers from the surface of Earth, and it is mostly non-detectable, but it is considered that it might exist even when there is sunset or sun disappears. So ionosphere is important layer of thermosphere related to the propagation of radio signals and therefore important to the Earth. The second important layer of thermosphere is exosphere. The layer of thermosphere above the ionosphere extending beyond 640 kilometers is called as exosphere. So exosphere is the outermost layer of the atmosphere. It is the uppermost layer of the thermosphere, which extends from 640 kilometers, that is the last limit of ionosphere, to 10,000 kilometers, that is the last limit of our atmosphere, which has been demarcated. And the density in this layer becomes very low, with the soaring high temperature exceeding beyond 5000 degree Celsius, because this layer continuously absorbs the solar radiation, high intensity solar radiation, short wavelength solar radiation. Therefore the temperature becomes very high in this particular layer. And beyond 10,000 kilometers, although there is no definite boundary, but it gradually merges with the outer space. So in this particular layer, as you can see, that the temperatures are continuously increasing. So the main characteristics of this layer in terms of temperature is, as we go up in the temperature increases with the height. So these are the 4 layers of atmosphere we have discussed. Now before summarizing it, I would like to quickly move to the summarization of temperature variations which are found in the atmospheric layer. As we have discussed all the major 4 layers of the atmosphere, I would like to quickly review the temperature variations in the entire atmosphere. Although we have discussed with each layer the temperature characteristics in that particular layer, but in this last slide, I would like to summarize the temperature variations, because the layers are demarcated, stratified mainly on the basis of temperature variations in the atmosphere only. So starting with the troposphere, which is the lowermost layer of the atmosphere. The troposphere takes maximum temperature from the absorption of terrestrial radiation. Therefore, the lower layers of the troposphere have warmer temperature as compared to the upper layers of the troposphere. So in troposphere, the temperature decreases with increasing height. So there is an inverse relationship between temperature and height in the troposphere. Coming to the second layer of atmosphere, which is the stratosphere. In stratosphere, the temperature increases with increasing height because of maximum concentration of ozone which is found in this layer, and the absorption of UV radiation which increases the temperature of stratosphere, and the higher concentration of ozone is responsible for that. In the third layer, which is called as mesosphere, the temperature again decreases with increasing height. So much so that towards the outer limit of mesosphere, it reaches minus 80 degrees Celsius, which is lowest among all the layers which are found in the atmosphere. So at 80 kilometers, the temperature in mesosphere is minus 80 degrees Celsius. Beyond this 80 kilometers, when we enter our thermosphere, which is the fourth outer layer of the atmosphere, the temperature beyond 80 kilometers only exceeds. So again in this thermosphere layer, with increasing height, the temperature increase. So there is an increase in temperature, and in this thermosphere, the temperature keeps on increasing to very high levels, reaching somewhere around 5000 degrees Celsius in its outer margins also. So you can see here that there are alternative bands, and the temperature variations is very much evident through decrease in temperature, then increase in temperature, then decrease in temperature, and then finally increase in temperature. So these alternate temperature variation bands are one of the significant characteristics of our atmosphere, demarcating our atmosphere into various layers. Coming to the summary now. So summarizing the whole video, the atmospheric structure, the layers of the atmosphere have been discussed in this particular video, and the atmosphere, though composed of several components, acts as a single unified envelope of gases that surround the Earth. So our structure of the atmosphere can not only be studied in terms of individual components, individual composition, but also in terms of various factors like temperature and pressure. So the structure of atmosphere is studied in terms of its composition, pressure and temperature. So primarily based on temperature, the atmosphere can be divided into four major layers, which stratifies the atmosphere into different vertical spherical layers which surround the surface of the Earth. So these layers on the basis of temperature variations which exist in them, on the basis of definite characteristics of atmosphere in different regions, the atmosphere is divided into four major layers. These layers are first the troposphere, which is the lowermost layer of the atmosphere. It is very, very important. Why? Because major weather phenomena takes place in this particular layer. It contains 75% mass of our atmosphere. Therefore, this layer is very important for biological life forms on Earth. The boundary between troposphere and stratosphere is called as tropopause, where the mixing of air stops. So stratosphere, being the second important layer of atmosphere, is comparatively stable when compared to troposphere. So because of its stability, the commercial airliners, they fly their jets in the lower regions of stratosphere. Stratosphere also becomes important because of the concentration of ozone gas, which filters out the UV radiations and shield our Earth from the harmful rays of sun, maintaining the optimum temperature on Earth. Third important layer is mesosphere. The boundary between stratosphere and mesosphere is called as stratopause. And here in mesosphere, the temperature again decreases with increasing height, so much so that at the outer limits of mesosphere, it reaches to minus 80 degree Celsius. So the upper limit of mesosphere is the coldest layer in all the four layers of the atmosphere. Fourth important layer of the atmosphere is thermosphere. So thermosphere extends from about 80 kilometers to 10,000 kilometers and gradually merges with the outer space. So thermosphere also is subdivided into two layers. The lower region of thermosphere has great concentration of ionized charged particles, and therefore this particular layer is called as ionosphere, which helps in the propagation of radio waves and radio signals. And the outermost part of the atmosphere and even the thermosphere is called as exosphere, which extends to about 10,000 kilometers. The temperature in this particular layer is very high, and it gradually merges with the outer space. So these layers, although they may have definite characteristics, they may have their definite temperature variations, they have their definite role for supporting biospheric system on Earth, including man. And each layer have definite significance to the Earth's biospheric system. They may have their individual role also to play for maintaining life on Earth, and they also act as a part of a greater umbrella atmosphere, which acts as a single unified envelope of gases that surrounds the Earth. So each layer with its definite characteristics may play a definite role, and they are part of a greater single unified system called atmosphere, which protects our Earth and makes life possible on Earth, makes our planet unique. So in this particular video, we have discussed about the structure of atmosphere and the layers of atmosphere. Thank you for hearing me out.